general form of a quadratic function. The general form of a quadratic function is any function of the form ax squared plus bx plus c. A, b, and c are just numbers. A is not 0. If a were 0, that term would go away, and what would be left? Bx plus c, which is the equation of a line. Yeah, we usually put an m there for slope, but it just stands for any old number, right? Okay, so for it to be quadratic, you have to have the x squared term. So a can't be 0. The graph of any quadratic function is called a parabola. It's a U-shaped graph that opens either upward or downward. Okay. So we're going to first talk about this in terms of transformations of the parent function x squared. Okay, so we spent a lot of time on transformations. So if we look at the parent function x squared, which is graphed here for you, the point 0, 0, that turning point, is called the vertex of the parabola. It's the vertex of x squared. All right, so here's that point 0, 0. And I'll mark a few key points on this graph. We've got 1, 1, 2, 4. That's good. Negative 1, 1, and negative 2, 4. So I've got 4 key points there. And I'm going to apply these transformations, right? So this is actually a really good review because transformations will be on the test on Friday. All right, so let's look at what's happening here. I've got a multiply by 2, I've got a subtract 1 in parentheses, and then I've got a minus 3 out of parentheses. Transformations. What's the only rule about order? Stretches and shrinks first. It doesn't have to be vertical, but any stretches and shrinks. Yeah, in this case, it is a vertical stretch, right? So we do a vertical stretch first, and how are we going to stretch vertically? How do we make that happen? The 2, yep. What are you going to do with that 2? Multiply what by it? Y values. If you want to stretch something vertically, it's the y values that you want to make bigger, right? So first thing I'm going to do is the vertical stretch, and that I do by multiplying the y values by this factor here, the 2. Okay, so for each of these, I've got 7 points here that are on the graph of y equals x squared. First thing I'm going to do is double the y values. So I get negative 3, 18, negative 2, 8, negative 1, 1, 0, 0, stays 0, 0, because doubling 0 is still 0. 1, 1, double the y value, I get 1, 2. 2, 4, double the y value, I get 2, 8. 3, 9, double the y value, I get 3, 18. Okay, so that takes care of the vertical stretch. Yes? Oh, whoops, that should be negative 1, 2. Thank you. Okay, so now I've done the vertical stretch. Now I can do the shifting. And the order that I do the shifting does not matter. So what do you want to do first? What does this minus 1 tell us to do?
Add 1 horizontally.
We're going to move right 1 horizontally, right 1. And to move to the right, I need to add 1 to my x values. Okay? So I'll do that next. I'm going to add 1 to each x value. That'll take care of my shifting 1 to the right. So negative 3 plus 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. And 3 plus 1 is 4. Okay. So I added 1 to each x value. That moves the whole graph to the right one. And then the very last thing I do is that minus 3 that's on the outside. And what does that indicate? Down 3. How do I change the points to move them down 3? Subtract 3 from each y coordinate. So I've got 2, 15, negative 1, 5, 0, -1, 1, -3, 1, -4. Oh, sorry. Lost track of what point I was looking at. Yeah, for 2, 2, 2, 2 goes to 2, -1. And then 3, 8 goes to 3, 5. And 4, 18 goes to 4, 15. Yes, thank you. Okay. So let's look at just the vertex. Oh yeah, sure. I'm not going to change anything. So the vertex of the parent function x squared was at 0, 0. Let's look at where that went. So 0, 0, it started at 0, 0. After applying the 3 transformations, it landed at 1, -3. Okay. So my vertex ended up at 1, -3. Could you have identified that point, 1, -3, by looking at the equation? Go back up to the equation for g of x. Do you see 1, -3 in there?
Yes.
Yeah. There's a 1, right? Right here, there's the 1. There's my -3. It's in the equation. Okay. So there's a 1, there's a -3. And then what role does the y-axis play in the graph of f? What's special about that line right there in the graph of the original parent? It goes through the origin, yep. It splits it in half, line of symmetry, yeah. It acts like a mirror for the graph of f, yeah. So we call that an axis of symmetry. And if I plot the points that I got for g, right, my final points, -2, 15, that's too big, -1, 5, 0, -1, 1, -3, 2, -1, and 3, 5. This is my transformed function g. Where is g's axis of symmetry? That's at 1. I know it's really hard to read the numbers. They're small. But this is the line x equals 1 is my axis of symmetry. I plotted the final list of points. Yeah. These are points on G. So you can see the transformations the way we described them. I've definitely got a vertical stretch. It looks taller or skinnier, whichever way you want to describe it. And then it moved right 1 and down 3. Yeah, yeah, x equals 1. Okay, so this is called the standard form of a quadratic function. If you write it in the form a times x minus h squared plus k. So in our case, a was a 2 in the preview exercises, h was a 1, and k was a -3. So what transformations from the graph of y equals x squared does the standard form represent? A vertical stretch and a shift left or right and a shift up or down. So what can we tell about a parabola from just looking at its standard form? The vertex, right? That's what's convenient about looking at the standard form, is that you can see the vertex, h and k make the vertex of the parabola. The leading coefficient of a, when a is positive, like it was in our example, the graph opens up or down? Up. And if a is negative, that would actually cause a reflection over the x-axis, so the parabola would open down. Large values of a make the parabola narrower. Smaller values of a, closer to 0, make the parabola wider. So if you want to make an accurate sketch, you find the vertex, you know whether it opens up or down, and then you could find an x or a y intercept to help you fill the sketch out. All right, I'm going to skip that. Okay, so how do we change from the form ax squared plus bx plus c, which is the form I gave you at the very, very start of class, to the standard form, which we like because you can get the vertex right from it? Okay. So it turns out that the a value in these two forms is exactly the same. So I call it a in both of them. So that part's easy. And then we just need to identify h and k. Okay, so I'm given this guy, so I just need to find h and k to finish writing this guy. So it turns out that to find the vertex of a parabola, if it's given in ax squared plus bx plus c form, h is negative b over 2a, and k is just the function value at negative b over 2a. What does that quantity, negative b over 2a, remind you of? The quadratic formula, and that's where it comes from. Okay, so I'm not going to derive it for you, but know that it's that value for a reason. Okay, so here's a quadratic function, negative x squared plus 4x plus 1. I'm going to change it to standard form so that I can graph it, right? It's easier to graph if it's in standard form because then I'll know its vertex. So what is the vertex of this parabola? Well, h is at negative b over 2a. And so negative b would be negative 4. And a is negative 1. So negative 4 over 2 times negative 1 is?
Wait, why is it negative?
Because the a value is negative 1.
Oh, yeah. Sorry, I was looking at C.
Dose. Right. H is 2. And then k, I get by just taking the value of h, right, and plugging it into the formula for f. K is always f of h, right? Because that's f of h means the y value when x is h, so that would obviously give you the k value. So I plug 2, now that I know what h is, I plug 2 into that function, and I get negative 2 squared plus 4 times 2 plus 1. So that would be negative 4 plus 8 is 4 plus 1 is 5.
Okay, the negative.
Correct. The negative is not in parentheses, so you do the squaring first and then make it negative. Yeah. So my vertex, my final answer, my vertex is a point. It's at 2, 5. All right, so now I'm going to write the quadratic function in standard form. So that is y equals a times x minus h squared plus k. What is my a value going to be? Negative 1, because it's the same a value as the function we started with. Okay, so y is going to be negative 1 times x minus, what is h? 2 squared plus k, which is 5. We did it. There's the standard form. Does that parabola open up or down? down because the a value is negative. How do you generally find the y-intercept of any function? Make x 0. So I could use either formula. I could use the one I wrote down in number 2 or the one I was given. They should give me the same thing. Those are equivalent functions, equivalent equations. So to find the y-intercept, which one is it easier to plug 0 into? The original, yeah, because anything with an x in it will just go away and I'm left with the constant 1. So I've got 1 for a y-intercept. So now I'm going to graph it. Vertex is at 2, 5. My y-intercept is at 1. And it opens down. So it's going to look something like this. Oh, sorry, I should have found the x-intercepts first. So we could be a little more accurate. Okay. How do you find, in general, how do you find the x-intercepts of a function? Yeah, make the y 0. So I'm going to have 0 equals, and I could use either formula I want, whichever one's easier. And that doesn't factor, I'll have to use the quadratic formula. So I get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's 16 plus 4 is 20 over negative 2. So it doesn't come out that nice, but I can still get an estimate. Use my calculator. Okay, so I've got negative 4 plus square root of 20 and divide that by negative 2, and I get negative 0.24. And then I also have to do the minus, right, because it's plus or minus. So negative 4 minus square root 20 divided by negative 2, and I get 4.24. Okay, so now I have even a little more information to use when I'm trying to sketch the graph. So I'll do all of it now. Plot the vertex 2, 5. The y-intercept was 1. And my x-intercept, I've got 1 at like negative a quarter, right somewhere in there. And then I've got 1 at like 4 1/4. And then I can just connect all these points with a parabola. Those are arrows at the end.
The y coordinates.
The y coordinates?
Yeah, the two
These two?
dots. No, not the x's.
This one? This one's the vertex, which we did up here. Yeah, 2, 5. The y-intercept, this one, I got by plugging 0 into the function. So you plug 0 into the function, so the point 0, 1 is on the graph. And then the other two I got from the x-intercepts. Any other questions? Crazy? Okay. I'll wait. So far, we have been given an equation and asked to draw its graph. 6? Oh, good question. Yeah. How would you change the function back into polynomial form? So we have it as negative x minus 2 squared plus 5. How could I turn that back into ax squared plus bx plus c form? Just do it out, yeah. So according to the order of operations, what's the first thing I should do here? Right, I should deal with the parentheses first. I can't actually do x minus 2 because they're not like terms. So the next thing would be the exponent. So this is going to be y equals negative x squared minus 4x plus 4. That's what you get when you square x minus 2 plus 5. And then I'm going to distribute the negative. Negative x squared plus 4x minus 4 plus 5. And finally, combine the like terms, and I get negative x squared plus 4x plus 1. That is the formula we started with. So you can always check. If I ask you to put something in standard form, once you're done, multiply it back out and make sure you got what you started with. Thanks for reminding me to do that. I agree. All right. So we can be given a formula and draw its graph. Like whether we're given standard form or vertex form, you could always put it into the vertex form and draw its graph. But what if I give you the graph? Could we come up with its equation? Sure, yeah. So here I've given you a picture, given you a graph. Do we know the vertex? Yes. So that means that the standard form is probably going to be easiest. So I'm just going to start by writing it down. Right. I'm going to use that form because I know the vertex, which means I am 2/3 done with this problem. Right. The only things I have to do is I have to figure out what is A, what is H, and what is K. Once those are in there, I'm done. And I have H and K. So I'll put those in, and I have A times x minus 3 squared plus 5. All right. I have one unknown left. I have one constant that I need to figure out what it is. What could I do? Use what formula? Oh. Negative b over 2a would have to equal 3. Get my y-intercept? Yeah, let's use the y-intercept. That will work, but I think it's a little more complicated. Yeah, so my y-intercept is 23. So what does that mean in terms of the equation? Pump in 23 on the y. What do I put in for x? When y is 23, x is 0. H and k are always, yes. Yeah, so now this is just a formula that we could solve for A. A tells you how tall or like wide or narrow the parabola is. Right? If this vertex were a little bit higher, this parabola would be narrower. It's our stretch and shrink term, yeah. So now I could solve for A, right? So this says 23 equals 9A plus 5. So 9A equals 18. So A is 2. Yes. So what does this process remind you of? Where you plug in a point and solve for the one remaining thing you need? Algebra, yeah. I was thinking of lines. Like once you have the slope, plug in a point and you get the y-intercept, right? It's a similar process. Plug in a point, find the very last thing you're looking for. -3. 0 minus 3 is -3. When you square it, you get 9. So am I done? Should I circle that A equals 2? No. I have to write it back in the general formula, a times x minus h squared plus k. Now I know all three pieces of the formula. Y equals 2 times x minus 3 squared plus 5. So now you can do either. If I give you a formula, you could draw its graph. If I give you a graph, you can write its formula.
And then 23IA.
Yeah, good question, Jesse. So Jesse said, could we just multiply this out and put it in the other form, the ax squared plus bx plus c? Yeah. So this would be fine if you left that like that on a quiz or a test, or you could multiply it out. X minus 3 squared is x squared minus 6x plus 9 plus 5. Distribute your 2, and I get 2x squared minus 12x plus 18, and then I still have plus 5, so I have plus 23.
So what's that right there? That's the same thing in a different.
Yeah, these two things are equal. They are the same. They're just two ways of expressing the exact same thing.
So one is in, what are those ones called?
This one is called vertex form,
And then the other one is
and then the other one doesn't really have a name. I call it polynomial form. Any questions? All right, I think that that's it. Yep, okay, go to work.